We've talked about multiplying and dividing rational expressions. Now we're going to talk about adding and subtracting rational expressions. And you've done this before. Basically, like I've said previously, a rational expression is just any type of fraction. So we've added and subtracted fractions before, and we know that rational expressions or fractions with like denominators are easy to work with. Denominators. Because we just add or subtract the numerator, the top part. And we don't touch or change anything about the denominator. So if our denominators are already the same or are a common denominator, then life is really easy. If we look down here at these examples, since the denominators are both 5x squared, we just add the numerator, 3x plus 7, 3x plus 7 over 5x squared. And we ask ourselves, can we simplify or factor any of it? And if not, that is our final answer. And we can't do anything with this. So this is how we're going to leave it. In this example, we have common denominators. There's a subtraction sign, though. So we know it's going to be over x plus 1, 9x to the third minus x squared. Well, we can factor the numerator because there's an x squared in common. So this is going to be x squared times 9x minus 1 all over x plus 1. So again, we want to factor, if possible, once we get our result. Down here, we got some examples. So I'll do A and B and have you try the others. So again, we have subtraction. Our denominators are the same. So 7 minus 2 is 5 over 12x. And we ask ourselves, can we simplify that? Most people forget to see if they can simplify the number part. We can't simplify 5 over 12, so this would be our final answer. Letter B, our denominators are the same already. So we're going to do 2x squared plus 2 over x squared plus 1. We can factor the top. The top, you can take a 2 out, and we're left with x squared plus 1 over x squared plus 1. And because we have the same thing on the top and bottom, we know that we can cancel those off, and this is just going to leave us with 2. So that's why we want to factor things after we add or subtract. So I want you to try these real quick. Remember that when we subtract, for this solo problem, when you subtract, it's got to go to both of these things. So pause the video. Once you're done, unpause it to see what your answer is. All right, so here are the answers. For the one on the left, you had to cancel out the 3 on top and bottom. Remember, when there's nothing on top, you have that invisible 1. And then the one on the right, remember, you got to subtract both things. What I mean by that is I did 4x minus 3x to get x. And then negative 7 minus 3 is negative 10. So that's how you get that answer. So that is a very common mistake to make. So let's look at the next page. Well, what happens when the denominators are not the same? We got to find the least common denominator. Another way to think about the least common denominator is say, what's the least common multiple of the two numbers on bottom? It's the same process. So if we say what's the least common multiple of the bottom numbers, or the denominators, it's the same thing as saying what is the least common denominator of the entire fraction. So here, with these problems, they're just basic numbers that we're used to dealing with. So on the fraction on the left, if I multiply the top and bottom by 2, that's going to be 4 over 10 minus 3 over 10, And now that the denominators are the same, you can take 4 minus 3, you get 1 over 10. Letter B, what we can do here is look at our denominators. We have 12 and we have 16. We can't multiply one of them to get the other like we did here. We multiply the left fraction by 2 over 2 to get 10, and we didn't do anything with this fraction. We can't do that over here. We got to multiply both fractions by something. So if I multiply by 4 over 4 and 3 over 3, this is going to give us 20 over 48 plus 9 over 48, which is going to be 29 over 48. Now, if you weren't able to see that the least common denominator in this problem was 48, you could multiply the fraction on the left by the denominator of the right one. So you could have done 16 over 16, and then the other fraction multiplied by 12 over 12. You would have had to do some more reducing afterwards, but you would still get the answer after you reduced. So let's apply this to polynomial expressions. We're going to factor both of these. The first thing I would factor out is a 3, and we're left with x squared plus 4x plus 4. Sorry, factor out a 3x. I'm sorry, factor out 3x. And then we can factor this. It's going to be 3x, and then we're going to have x plus 2 times x plus 2, or 3x times x plus 2 squared. Then over here, we can factor out a 6x squared, and we are left with x squared plus x minus 2. And we ask ourselves, what two numbers, or can we factor this, what two numbers multiply to negative 2 but add to 1? So that's going to be x plus 2 and then x minus 1. So common factors between these two. I think we can all agree that they both have an x plus 2 in common. I think we can all agree they have an x in common. Here's x, and this is x squared, so they have an x in common. But when we look at the 3 and we look at the 6, they both are divisible by 3. Even though you don't clearly see a 3 in the left one right here, 6x squared, but we know that 3 is a factor of 6. So the common factors we have here are x plus 2, x, and 3x. So the difference between those factors, like what do we notice about them? Well, like I was saying, one of them is a number that doesn't appear in letter B. We don't see number 3 in letter B, but we know that it is a factor. We don't see x to the first power in letter B, but we know, since we have an x squared, that it is a factor of that. And then we see x plus 2. So down here, let's look at these two problems and see what are some similarities and what are some differences. Letter A is just using regular old integers or numbers, and we're finding a common denominator by multiplying the left fraction by 3 over 3 and the right fraction by 2 over 2. And then once we get common denominators, we know we can add the numerators up and simplify if needed. Over here in letter B, first we factored everything that we could, because once you factor things, you can easily see, how can we get the least common denominator. So once everything is factored, we see that the left fraction is missing an x plus 3 that the right fraction has. So we multiply the top and bottom by x plus 3. Then we see that the fraction on the right is missing an x. There's no just x to the first power there. So you see that we multiplied the top and bottom by x. And then we distributed on top, but left the bottom alone. So I hope you can recognize that. We took 2 and multiplied it by those to get 2x plus 6. And then x times x is x squared. But then the denominator is in all factored form. And then you combine like terms in the numerator. And then you check, is this factorable? And it happens in this case, it's not factorable. So it's the same process, it just looks a little bit more confusing. It might take a little bit longer, but we found a common denominator. So we found a common So on the next page, I kind of mentioned this earlier, that figuring out the least common denominator is the same thing as figuring out the least common multiple between the two denominators. So we're going to do some practice calculating or figuring out the least common multiple is. So between 3 and 3, the least common multiple is just 3. Between x and x, the least common multiple is x. X plus 2 and x plus 2, the least common multiple is x plus 2. Now we have 3 and 9. These are clearly different. So the least common multiple between 3 and 9 is going to be 9. If you want to think about it as, all right, if I had 1 over 3 plus 1 over 9, what would my least common denominator would be? Well, that would be 9. Now the second one, or sorry, the second one, letter E here, we have x plus 2 and then x plus 2 to the second power. Now when we have something like this, whatever the highest exponent is, or highest degree, that one wins. So what I mean by that is my least common multiple is going to be x plus 2, but squared, because that is my biggest exponent here. Letter F, between 3 and 2, remember I also said that one of the ways you could find the least common denominator is multiply them. We get 6. Or again, you can say, okay, if I have 1 over 2 plus 1 over 3 plus 1 over 2, what would that be? Like, what would the least common denominator be? Now, letter G, x and x squared. The biggest exponent is x squared, so our least common denominator, least common multiple will be x squared. Now, letter H is where it gets a little bit interesting. Between 6 and 4, what is your least common multiple between 6 and 4? Well, that's going to be 12, because 2 times 6 is 12, and 4 times 3 is 12. Now we have x plus 1 squared and x plus 1. Well, because that x plus 1 in the first column is a higher exponent, or the highest exponent is 2, the x plus 1 squared. And the first column doesn't have an x minus 1, but the second column does, so that means your least common multiple would also have an x minus 1 in it. So if we look at letter I right here, nothing looks to be remotely common at all. But if we factor both of these expressions, factor out of 5, and now we have a difference of squares, so we have x plus 3, x minus 3. And then over here, if we factor out of 4, we're left with x squared plus 6x plus 9. And then we can factor that to x plus 3 times x plus 3, or x plus 3 squared. And now that everything is in factored form, it's easier to calculate or figure out what our least common multiple will be. So between 5 and 4, the least common multiple is 20. And then we have an x plus 3, but we have x plus 3 squared in the second column. So our least common multiple for that part will be x plus 3 squared. And then we have x minus 3, but no x minus 3 in the second column, so it's going to be x minus 3 is our least common multiple there. Now this one down here, j, we can't factor anything in the first column, but in that second column we can factor out a 5x, and we're left with 2x minus 3. So our least common multiple for this one is going to be 5x to the third, because we have 5x to the third in the first column, but 5x to the first in the second one, so we have 5x to the third as least common multiple, and then 2x minus 3. All right, now the last one, we can factor out an 8 from the first column. We're left with x minus 2. We can factor out a 12, and we're left with x squared plus x minus 6. And then factor this to x plus 3 times x minus 2. So we can hopefully all agree that x minus 2 is in common with both of these. But I like to do the numbers first. Not greatest common factor, least common multiple between 8 and 12. Well, that's 24. 8 times 3 is 24, and 12 times 2 is 24. X minus 2, x minus 2, they're both to the first power, and then x plus 3. So we're going to be using this skill of finding the least common multiple to figure out the least common denominator, and that will let us add or subtract these rational expressions. So the smallest common multiple of two or more numbers or terms is called the least common multiple. And the least common multiple of two denominators is the least common denominator, or least common denominator. Abbreviated LCD. So when I ask you to find the least common denominator, what that really is asking you to do is to find the least common multiple of the two denominators in our rational expressions. So down here, let's add these two expressions. And I mentioned this before, that if you're unsure, you could always multiply the top and bottom of one fraction by the denominator of the other fraction. Let's use these colors. And you would have to do some more simplifying. So if I did that here, I would get 4 over 24 plus 6 over 24, which would be 10 over 24, and that would reduce to 5 over 12. Okay. Or if I would have recognized that I could multiply the first fraction by 2 and the second one by 3, this is going to give us the answer a little bit quicker. And I know you might be saying, well, this isn't really a big deal, just one extra step. And I would agree with you. When we're working with just integers like this, dealing with one extra step may not be an issue. But when we have a bunch of factored terms or linear factors, that could be an issue and start to get frustrating. So down here, to add or subtract rational expressions with unlike denominators, find a common denominator and rewrite each rational expression using that common denominator, then add or subtract. So if we look at example 3 here, the common denominator between 4x and 7, well, I'm going to have to multiply one fraction by 7 and the other one by 4x. That's going to be 21 over 28x minus 4x over 28x. And that is going to be 21 minus 4x over 28. And since we can't do anything to reduce this, that is our final answer. Example 4. All right, I want to factor the denominator first, if possible. I can't factor the first one, 1 over 3x squared, but I can factor the second one. I can factor out a 3x, and then I'm left with 3x minus 4. Now, to add these, we need a common denominator. So I would write that over here. The least common denominator is going to be 3x squared, because we have 3x squared and 3x, and multiplied by 3x minus 4. So then we're going to multiply each fraction by what's missing. So what do I mean by that? If I look at the fraction on the left, 1 over 3x squared, and I look at my least common denominator, the thing that it is missing is this 3x minus 4. And then the fraction on the right, what that is missing is having that x, this x right here, raised to the second power. So I need to multiply the top and bottom by x. So I'm going to distribute in the numerators, but I'm going to leave the denominators in factored form. So I'm going to have 3x minus 4 over 3x squared times 3x minus 4. And then my second fraction is going to be x squared over 3x squared times 3x minus 4. Now I can add my numerators. There are no like terms. So I'm going to have x squared plus 3x minus 4 over 3x squared times 3x minus 4. And as I said earlier, or when we were looking at that sample problem, you want to see if you can factor the numerator up here. Because what if you could factor the numerator and you get a 3x minus 4 that could cancel with what you have in the denominator? So when you look at the numerator, you factor that, you get x plus 4 and x minus 1 over 3x squared times 3x minus 4. And that would be our final answer. So in this problem here, we're going to first factor the bottoms. So factor out a 3, we're left with x minus 5 minus, now that's important that we have that here. It's going to maybe trip some people up. And then we factor the denominator. We're going to have x minus 5. There's x plus 1. So now our least common denominator, or LCD, is going to be 3. X minus 5 is x plus 1. And then we go and multiply the first fraction by what's missing, which is going to be x plus 1 over x plus 1. And then we're going to do the same thing for the other fraction, multiply by what's missing, which is just 3 over 3. Distribute the top, but the bottom I'm going to leave in factored form. So x squared plus x over 3 times x minus 5 times x plus 1 minus 6x plus 6, because we're taking the 3 and distributing it, over 3, there's x minus 5, there's x plus 1. Now that the denominators are the same, we can combine like terms in the numerator. So x squared, I only have one of those, so x squared. We have x minus 6x, so that's negative 5x. And then 0 minus 6, that's going to be minus 6 in the numerator. Because remember, this negative sign has to go to both things. Over 3 and x minus 5 times x plus 1. The numerator can be factored. It can be factored into x minus 6 times x plus 1. And that's over 3 times x minus 5 times x plus 1. And because we have an x plus 1 in the numerator and denominator, we can cross them off. And then that's going to leave us with a final simplified expression of x minus 6 over 3 times x minus 5. So yeah, this is a process here. So it does take time, and it's very easy to make a mistake. So what I want you to do is pause it and try the problem on the left over there. And once you're done, unpause it, and we can chat about what you got. All right, so you can see what I got over here. Take a minute to check your answer, and if you didn't get the answer, you can look back at my work to see where you may have messed up at. This stuff is time-consuming. Like I said, it's a process, so please make sure you're taking your time to do your math carefully. But this is something that is going to come up for the rest of this unit. So if you need to rewatch this, rewatch it. Do the practice problems again so that you have an understanding of how this works. So thanks for watching. Make sure to like this video and subscribe.